Hi, everybody. This is Kubernetes Workgroup Device Management for October 14th. Okay, let's get started. I will show the screen, the agenda. And let's see, I didn't pull any of these future meeting items, but if we have time and folks are here, we can cover some of those. Other than that, there's just two items here on the list. John, you're up first.
Cool, thanks. Yeah, so I just wanted to call out that I have a KEP that's ready for review. This is a new alpha KEP that I'm hoping to land for 135. And kind of the gist is that we want some way to kind of short circuit the kubelets retry loop in node prepare resources where, so basically to allow drivers to indicate back to the kubelet, like, hey, if you retry again, this is still not going to work. So if we can kind of short circuit that and get the pod into some sort of failed state, so then higher level controllers can kind of more proactively handle those situations. That's kind of what this KEP is aiming to do. So I think Sergey has already taken a look at it. Patrick's taken a quick look at it, but I would love to get some more feedback. I'm looking at Kevin in particular, since I know the NVIDIA driver is doing some kind of related stuff to this already. So any practical feedback especially would be most welcome there.
I'm planning to
Sorry,
take a
Kevin,
look
go
at
ahead.
it. Sorry, I thought you were done. Go ahead. I'll
yeah.
say it after you're done.
No, go ahead. I was done.
I was just going to say, yeah, I'm planning on taking a look at it. And as you pointed out, we've been anticipating something like this to eventually appear, because in our DRA driver for GPUs, we return the notion, at least internally, of a permanent versus transient failure. And the permanent failures stop our own internal retry loop and return back to the kubelet. So if we had a way to pass that permanent error on and have the kubelet actually fail it, that would be much better than the current state of things. Yeah.
And Kevin, with that, if you know you're in a, and John too, if you know you're in a permanent failure mode, shouldn't you, for future scheduling decisions, be today withdrawing all those devices and maybe in the next release when it makes beta, hopefully tainting them? Or what is this?
Depends on what the failure is. So like sometimes permanent failure is someone's opaque config was misconfigured, and you're never going to be able to fix that because it's a user input error. Ideally you catch this in the webhook, but if you don't have a webhook, then you need to catch it in the plugin, and you're not going to be able to recover from stuff like that. So it's not necessarily actual device allocation failure. Sometimes it's something else. Yeah.
It would be interesting, and I haven't looked at the KEP yet, so maybe this is in there, John, but if we can differentiate between those things, right? Like a user error, you don't even want to retry scheduling that to another pod if you can avoid it, right? Like you just never want to, you just want to basically put that, never try that one again. If we could communicate that all the way to the scheduling layer, that would be nice. I see a couple of hands though. Unless you have a response to that, John, I'll start the hands.
Yeah, just a quick response to that. So yeah, there is some discussion of that in the KEP. I think right now there isn't any proposal to like actually handle those things differently. Basically the driver will respond saying like this is a permanent error, and then the pod will become failed, and that's kind of it. But I did mention in the KEP that like tainting the device may or may not be applicable, so that's something that drivers should consider doing if that would actually help things. But yeah, I do see where like even rescheduling a user error might not actually help. So I'll definitely think about that more. Well, I think Dominic's hand was first.
Right. So there was one concern about binding conditions and the question whether schedulers should retry binding failures. So I'm not completely sure that this KEP is about binding failures or failures that will happen later. But yeah, probably in both cases we have a similar problem.
So this one's later. This is after you've been bound to the node and the kubelet calls the driver to try to actuate, or really before it builds it, like it's ready to generate the CDI files, basically. And it can fail. So this is later, after it's already bound. But I think that's I didn't need to read, I saw you left a long comment on the binding conditions. I haven't had a chance to read it other than scanning it in my email over breakfast. But is that what that's about, or is it different?
Yeah, there are two things. The one comment was that if we just consider binding failures and ignore the problem of device attachment, then we still may need to have a similar feedback loop, whether the failure should be retry or the failure is permanent.
Okay. Gaurav?
Hey, so in some testing that we have been doing for DRANet, we have observed, I think, what appears to be failures where the scheduler has some race condition during higher pod churn and it incorrectly assigns the pod to a node which does not have the correct device. So I had two questions, like, are we expecting such failures? Because I do see mentions of some race conditions in the structured parameters kept. And if we are expecting such failures, then is this kept going to be a solution towards handling these incorrect assignments? Because otherwise the pod just remains stuck in that indefinite state and there is no way to make forward progress, right? So are these
So
connected?
the answer to the first question is no, we should not expect that. That should not happen. That sounds
Okay.
like a bug.
Okay.
So if you can reproduce that, that would be really, really good to fix and backport to 134. Yeah, if you've got some instances of that, there must be a race in there somewhere, but there are races we intentionally avoided. We know there could be races between concurrent schedulers, but that's not a thing we support because we don't. But I would not expect a race within the scheduler. That's a missing mutex or something weird going on there.
I think also the second part to the question was about the KEP that John's proposing doesn't deal with bouncing the pod back to the scheduler to try and have it reschedule. It's just about permanently failing so you don't keep recalling prepare resources and instead put the pod in a permanent failure so that a higher level controller can detect that, potentially delete it, and then put it back on the scheduling queue. But there's no automatic bounce back to the scheduler to be able to deal with a potential problem that shouldn't even exist, as other John was just explaining.
So got it. Thanks, Kevin and John. So if we were to implement this skip and if the pod were to be marked as failed, do we know if the current behavior is that the scheduling would be retried, or do we don't know that yet?
You wouldn't, not by default. That's what I was just saying, is that you would just put the pod in a permanent failure state and some other controller would need to detect that and do something about it.
Right. So it depends what kind of controller you're using to manage those pods.
Yeah, we have I don't know if it ever turned into a KEP, but we had a Google Doc many months ago about different proposals for how to actually bounce pods back to the scheduler if they were in a kind of permanent failure mode. But I don't know what the progress on that's been. Francesco was leading that. I don't know if he's on the call. But yeah, I don't know what state that's in.
I saw Peter on the call because that was a SIG node. It was like over a year ago, I believe.
It was a while ago. Yeah. But that was more in the context back when we were talking about I think it was when we still had classic DRA and we wanted a mechanism to be able to force the pods to go back to the scheduling loop so that the control side of classic DRA could handle them again.
Yeah, okay, so Francesco, that KEP in SIG node, whatever happened to that? There was a discussion about
hello. So the original idea was exactly that, to tell the kubelet to tell the scheduler, hey, this node cannot accommodate this request in this stage, so try another one versus observing the loop, which we can also see in current kubelets in some cases. And basically, the work I had a rough draft and basically stalled because I did work on other stuff. But if there is interest, I can resume this work and will bring my stuff for 36 at earliest.
And I think where this would be most useful in the context of DRA is when there is some kind of race between a GPU, say, goes unhealthy, and the scheduler's already scheduled it to the node. So it lands on the node. You try to prepare it. You say, hey, sorry, this GPU that the scheduler scheduled to me is actually not available anymore. If you could communicate that back to the kubelet in the form of a permanent error for this node versus a permanent error in general because of user input or something, then you could use this mechanism to bounce it back to the scheduler so he could just try and reallocate it somewhere else.
I can resume this work. Yes, we can also talk in this session or another session, so we can make progress.
Dominic, you're muted.
Right. So my longer comment was actually about like going back into scheduler and how to avoid races. So basically, when we allocate in resource claim the driver, we may have a loop back from the driver to the resource claim, saying that the resources are good, accepted or not accepted. We can combine it with our nomination approach. So we have a nominated node, so kubelet can observe the resource claim for the nominated node and give some feedback whether the allocation is fine or not. Yeah, you can read the comment. It's about a bigger proposal, but basically this is how we could handle the attachable devices. So we can use a resource claim to reserve the device, and we will always hold this resource claim. But the allocation of the actual attached device would have to be handled in the device driver itself. So probably you would have to change where is the source of truth for the allocation, to not hold it in your resource claim, but rather to hold it in your resource slice.
That's challenging, but we can talk about that in another context. Okay, awesome. And I guess the general, if there's no specific comments on this cap, I will say generally, right, we're just a couple days from cap freeze. So if you owe reviews to people, please get to them ASAP. Yeah, there's a few caps out there, and some have already merged and are already ready for cap freeze, but I know there's a number that are not. So, anything else, John, or should we move on to the next item here?
No, that was great. Thanks, everybody.
Okay, well, the next item is more just FYI. So we were talking, and I realized as I published this that I meant to go back and circle around with Jack about, because I said SIG Auto Scaling was also a sponsor, so I hope he's okay with that. But I forgot to. But thank you. So the idea is, we talked about this in the past here. We've got a bunch of stuff going on in scheduling, and it relates to this group, but a lot of it's not directly related to the things we do, but it is, we're in this constellation of things around workload aware and topology aware scheduling and auto scaling. So workload aware meaning you look not pod by pod, topology aware meaning you look at the infrastructure and how it's racked and stacked and networked, and try to drop those workloads onto topologies that they'll perform best. And we want to take that beyond just scheduling, but to auto scaling as well, right? You want to be able to say, I need a new whole rack provisioned, right, for this workload, because I can't split this workload across multiple racks. So even though I have space for it in these 3 racks, I really need a whole new rack provision because it'll perform terribly otherwise. So that those all go together, and they all go with device stuff, because at least for me, I suspect that using DRA to model some of this topology and some of these things like compute domains, or even like GB200s, or TPU slices, something we have at Google, and other ideas might be useful in doing topology-aware scheduling, or in modeling the infrastructure. So anyway, the point being, we have about space for about 30 people in person. And so what this registration thing is like, I want to find out how many people want to be there in person. And then we'll also have a virtual Google Meet or something to go with it. But honestly, the whole point of this is rapid synchronous communication, which is hard to do virtually. So I think the online bit of it will be more observational with occasional, chiming in. So if you want to be like deeply involved in the design discussions here, trying to plan out the next several releases, kind of a roadmap like we do with the DRA, right? We have that set of that slide with the set of caps. We're trying to sort of plan out a roadmap. We'll try to do the same thing around this topic.
Is this the same day as the co-located events like AI Day?
It is. That's the only day, because Sunday is the Maintainer Summit, Tuesday through Thursday is the conference. So it's an all-day thing, but you can drop in and out, right? So if you're like, okay, I'll be there in the afternoon, put that in the comments in your thing, or if you can't be there at all, that would suck. I'd love you to be there, Kevin. But if you can only be there part of the time, let me know when that is, and we'll have some sort of agenda to at least, and we'll try and organize it such that the right people are there at the right times for the right parts.
Mm-hmm.
I know several people are like, well, I have a talk at this co-located event and I have to go do that. It's like, fine, go do that, but hopefully you can make it back. We couldn't get space in the CNCF, so it's at the Google Atlanta office, which is not right next to the conference center.
Yeah, okay. Got it.
So that's it for that. Unless there's other questions, then it looks like Gaurav snuck in an item here. So you're just asking on status here?
Yeah, I just wanted to follow up on this fix that Kevin and Patrick had investigated, I think a couple of weeks ago, and made a fix for this deadlock. Like, by when could we expect to have this available, and if there's anything that we could help with to like get this out sooner, because this is like really hurting us. Basically, like it means.
Yeah. So I can give context there.
Yeah.
So we became aware of the issue on a Friday afternoon. I spent the weekend debugging it. Patrick put a fix together on Monday, and the Friday when it was found is when the cutoff for 134.1 had happened. And so we weren't able to get this into 134.1, and we have backported. It's all ready to be in 134.2 whenever that happens. It's just, we got stuck on like the very last day and missed the boat for 134.1. And so now we're stuck waiting for 134.2 to come out, but the cherry pick has already happened, and it's going to be part of that next 134 release.
Got it. Is anyone over here like part of the release team and know when that is happening? Because I saw the date it's supposed to happen like sometime this week, but wanted to see if someone is like more closely involved with the release process and knows if there's been some progress on the release here.
Next week, an email went out during this meeting saying that it's delayed until next week. So
Okay. I see.
Yeah. It's unfortunate because we're also not allowed to backport this to 133 or 132 or any of those because DRA was not a GA feature, and you're not allowed to backport bug fixes for non-GA features. There's a couple things that are in 134 that we haven't been able to backport, unfortunately.
Oh, I thought this one was a regression.
This one isn't, but there are other bugs. Let's put it that way. There's at least one other bug that we encountered in 133 that's been fixed in 134, and we can't backport it to 133. It's a very rare condition, and John, we should actually talk about this. I meant to mention it to you because it happened in a GKE environment. But if for whatever reason the you have resource claims that are allocated, and you restart the controller manager, so like the separate component for the controller manager, which has the DRA controller manager embedded in it. Upon that restart, it loses track of those claims, and they never get deallocated. They just hang around dangling forever. And this is a known bug, and it was fixed in 134, but we've never been able to backport it to 133. And the problem with this is that if you have, resource claims that are allocated to something, those pods go away, the resources never get unprepare called on them. And so they're just stuck. The resources are stuck never to be allocated again, because they're not able to be released from those claims.
So it's a resource leak. Do we have if we don't have we can't fix it, we can mitigate, right? Can we scan
we can't change the that's the problem is we've at least, unless we can make a really good argument that so many people have, even though DRA was a GA feature, people have turned it on by default in different CSPs. Maybe that's a strong enough argument to say we should allow a backport in this particular case, but I haven't personally proposed that as something that we should possibly do, but maybe it's worthwhile given that you really can run into this in these, production environments.
Yeah. I mean, I think probably what we do in GKE in that case is we do a node repair or something that would basically, throw away, destroy the node and rebuild it, and then.
I mean,
Right.
that's what our team did when they encountered this. We tracked it down to being related to this exact bug, but because in GKE we don't have access to the control plane nodes, we couldn't actually verify that this was the bug because we couldn't look into the logs of the controller manager. I think we put in a request, but it was taking too long, and so we just decided, we're just going to decommission this node and put another one back. And then those resource claims were still dangling, but at least they weren't pointing at any resources that could be allocated anymore anyway. But our assumption is that something triggered the restart of the resource claim controller. Or sorry, the resource controller that's embedded.
There's lots of reasons to restart. Yeah, right.
Yeah. Because that was the exact symptom that we were seeing. And we reproduced it on a local cluster by just allocating similar or running similar workloads to what we were running in that GKE environment, and then manually restarting the resource claim controller. And upon it coming back up, all those claims were stuck forever. And that was specifically in 133.4. And
well, it looks like AWS, Geeta, AWS, if AWS and Google and I don't know about Microsoft and Red Hat, all kind of are like, we'd really like this backported. I think we might be able to convince people. So if somebody wants
there is an issue, we want +1s or something, happy to do so. I'm aware of customers running with 133, would help to backport.
So could you maybe tag us on that, Kevin, on the bug fix, or whoever did it, have them tag us, and we'll make a cherry pick request, and then we can.
Yeah, I can go ahead and open the cherry pick. I know exactly which bug it is, and then in the cherry pick description, I can add some more context as to why this is important. And then I can ping you guys. Yeah,
we'll try for some votes, and we'll see if the team will go for it. Okay. Awesome. Any other topics? then let's wrap it up and get half an hour back to finish your caps and reviews. So thank you, everybody, and we'll see you in a couple weeks.
Yep. Bye. Thanks.